Hi everyone, welcome to our second video lesson on Chapter 13. We're on 13.2, stem plots. Sometimes they're called stem and leaf plots. So if you ever hear that, it's the same thing as what we're talking about right now with stem plots. So here's what stem plots are used for. They're used for large sets of quantitative data. Just like our histograms were, stem plots can be used for the exact same data. It's best used when the data is close together. So if the data is very widespread, stem plots aren't probably the best graphical method to organize your information. But if all of the data entries are pretty close together, stem plots work really well. So when we compare the two of them, they display the same data. We could use histograms and stem plots for the exact same information. With stems, however, one thing that's kind of nice is you get to see each an individual data point. Remember with histograms, we just saw like in between the 60s and 70s, for example, was one bar. You couldn't see how many people got a 63 or what people got a 68 or something like that. With stem plots, you get to see each and every individual data entry. It will look the same if the classes are the same. So like this class right here is a class of 10. So then from 70 to 80, the stem and leaf plot will look the same as the histogram if the classes are the exact same. In histograms, you get to choose your classes. Not so with stem plots. They're more so given to, and we'll talk about that more as we go through our notes for today. Okay, some of these are review from histograms, but there are some new terms here as well. The range is just the maximum number minus the minimum number. The difference means subtraction, so you take the maximum value and subtract the minimum value, and that's what the range is. The median is the number in the middle, so when you organize them largest to smallest or smallest to largest, whatever, the one that's in the middle is going to be the median. We also call that Q2. Q2 and the median are the exact same. It means the exact same thing. It's the number in the middle. You might have to average the two middle numbers. If there's an even number of data entries, let's just take 6 data entries for example. Let's say there's the numbers 4, 7, 10, 13, 16, and 20 for example. So the average is the one that's left in the middle. So we go 4, 20, 7, 16. So we would have to average these two in order to get the median. So if there's ever an even number of data entries, you will have to average the two of them. If there's an odd number of data entries, let's just say for example that we took out this 20. If there's an odd number of data entries, you will not need to average. The 4 and the 16 go, the 13 and the 7 go, so the 10 is the median, or it's Q2. Okay, so now if we do the average of the lower half, or not the average, if we do the middle of the lower half, that's called Q1, or sometimes we call it the lower quartile, or the 25th percentile. Bottom line, those three mean the exact same thing. It would be the average of the the median of the lower half. And then Q3 is the median of the upper half. And I'll explain how to find that in just a little bit. The quartiles, quart means 4. So what quartiles do is it divides the data up into four equal parts. So if we have the data that's, let's say, goes from here to here, the median is what's in the middle. Okay, so let's say this is Q2. And then the middle of the lower half is Q1. So this would be Q1, and then the middle of the upper half here is Q3. So that's why it divides it up into fourths. Here's a fourth of the data, here's a fourth of the data, here's a fourth of the data, and here's a fourth of the data. So the three quartiles divide the data up into 4 parts. The interquartile range. Class, remember the range is the maximum minus the minimum. It's the difference of the highest and the lowest. So the interquartile range is again a difference, but it's the difference of the quartiles of Q3 and Q1. So to find the interquartile range, or the IQR, it's Q3 minus Q1. So we can even write that down right here. Q3 subtract Q1. The reason why the interquartile range is important is because now outliers, we have a specific method on how to find outliers. It used to be where it was kind of a guessing game. It's like, I think this is an outlier, it seems to be, but there was some gray area. Now there's no gray area, it's black and white. Data that is more than 1.5 interquartile ranges above Q3 or below Q1, that's data that's way different compared to the rest. We now know for certain that statisticians call that an outlier. Okay, so I'll explain how to find that. It's not any guessing anymore. There's a specific way of finding outliers. 1.5 times the interquartile range. Add that to Q3. Subtract it from Q1. Anything outside that range is an outlier. You'll see how to find that in our notes for today. So here's where we're going to get started. This is a stem and leaf plot right over here to the right. So you can see the stems here are 5, 6, 7, 8, 9, 10. All of these are stems all the way down to 18. And then the leaves are what comes off of the right, the 7, 5, 6, 7, 9, 6. All those are the leaves. Now one thing every stem and leaf plot should have is it should have a title. So this is inaccurate in two different ways. One, it should have a title. We don't even know what these numbers mean right now. But every stem and leaf plot should have a title. And it also should have a key. So for the sake of this one, everybody, here's what a key looks like. 5-7 means it's the number 57. You could say 5-7 equals 5.7, or maybe 5-7 equals 5,700. You got to let your reader know what these numbers mean right here. And the only way they'll know what they mean is if you write a key. So for our sake on this problem, let's say 5-7 equals 57. So this is 57, this is 85, this is 96, this is 97, here's 99, 106. Hopefully you get the idea. Okay? So now we're going to start filling in some of the things that we know. And we might not go in the exact order that I have written here on the smartboard, but follow along with me. The range is the highest number minus the lowest number. So 176 is the highest number. Subtract the lowest number of 57. So if we take 176 and we subtract 57, we get 119 is our range. 119. The spread of the data ignores outliers. It's the highest, or it's the lowest number, the highest number ignoring outliers. So we have to find the outliers first, so let's wait on the spread. Now let's find the median, and let's find Q1 and Q3. So the first thing we have to find when we find the median is how many data entries there are. So we would have to count all these up. We would say 1, 2, 3, 4, 5. For the sake of our example problem, I've already counted them out for us. There are 50 data entries. So 50 is an even number, which means that the median, or Q2 in this case also, is going to be the average of the 25th and the 26th. Remember, whenever you have an even number of data entries, you have to average the two middle to get the median. So let's count to the 25th and 26th data entry. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So these two right here, my friends, this is Q2, or the median. It's the average of 125 plus 127. So 125 plus 127 divided by 2. Our median, our Q2, is 126. Okay, so right here, the average of these two is Q2. So now we got what we want to find next is we want to find Q1. So Q1 is the median of the lower half. So here is the lower half. So I want to find the median of that. So there are 25 data entries here in the lower half. So my middle is going to be the 13th data entry. Right here again is where Q2 is. So now I'm going to say, well, the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This right here is where Q1 is. because there's 12 data entries below it, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 data entries above it. So 116, or 116, is our Q1. We'll do the exact same thing for Q3. It's the median of the upper half. So here is the upper half of the data, and we're going to find the middle. Again, there's 25 data entries on the upper half, so we're going to go to the 13th data entry. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This right here is Q3. Because there's 12 below it, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 above it. So 134 is my Q3, or 134. Okay, so to find the median, you take the middle of the data. To find Q1, you take the middle of the lower half. To find Q3, you take the middle of the upper half. Okay, next thing we'll find is the interquartile range. So that is the Q3 minus Q1. So 134 subtract 116. Our interquartile range, when you subtract those two, is the number 18. Okay, now our outliers. Pay very close attention on this part because this part is very important. Our outliers are more than 1.5 interquartile ranges above Q3 or lower than Q1. So we got to take our interquartile range. So here's kind of our outlier work here. Our interquartile range is 18. We got to multiply that by 1.5 because it's 1.5 interquartile ranges above Q3. So if we multiply 18 times 1.5, we get the number 27. So any numbers that are 27 greater than Q3. So Q3 is 134. So if we add 27, 134 plus 27 is the number 161. If there are any data entries that are bigger than 161, bam, that is an outlier. It's more than 1.5 interquartiles ranges above Q3. Do we have in our data set any entries that are greater than 161? Yes, we do. 176, you are greater than 161. 176, you are an outlier because you're more than 1.5 interquartile ranges above Q3. We got to do the same thing to see if it's less than Q1. So Q1 is the number 116, and we have to subtract the 1.5 interquartile ranges. So subtract 27. 116 minus 27 is the number 89. Are there any numbers lower than 89? Because that would be outside the data. So 89, are there any numbers less than 89? Yes, there is. 85 is less than it. So 176, you're an outlier. 85, you are also an outlier. Oh, and this one way up here, sorry about that, everybody. This one right here, 57, is also an outlier. So there are 3 outliers in this one because the interquartile range times 1.5 gives the range of 89 to 161. All of those are pretty typical of the data. Anything smaller than 89 is an outlier, and greater than 161 is an outlier. Okay, I hope that makes sense. We'll have another opportunity to go through that again coming up here in a few slides. The shape of this one, if you take a look here, it's maybe a little bit difficult to see at times. But if you kind of almost turn your head and see this as if it were a histogram, you would kind of see that it would kind of go like this, and then it kind of peaks in the middle, and it kind of goes back down. I would say this looks like pretty symmetrical data. Would you agree with me there? This is symmetrical. Not skewed one way or the other. This one is symmetrical data. Okay? All right, we'll talk about these examples in class. Let's now talk about how to make a stem and leaf plot. And this one's going to be a back-to-back one. You'll have a couple of these on your worksheet for today. So here's Tom Brady and Drew Brees' touchdown pass data for the seasons of 2001 to 2013 for Brady and 2001 to 2013 for Drew Brees. So the first thing we're going to need is we're going to need a title. So we'll title this maybe NFL quarterbacks touchdowns. Okay, something like that. Just a little something that lets the reader know what you're talking about. Okay? So if we take a look at our touchdowns kind of range from 0 touchdowns Brady had one season. He was injured that season with a neck injury. The highest is, let's see, 50 Brady had one season. Did Drew Brees have any above 50? No. So it looks like the highest is 50 and the lowest is 0. So I would say it would make sense here to have our stems be the tens place, or 0. Let's bring this down a little bit here. 0, 1, 2, 3, 4, and 5. And we'll have, because Tom Brady is on the left side, we'll have Brady over here. And Breeze we'll have over here. We're going to make 2 stem and leaf plots, but kind of on the same graph. Okay? All right. So Brady has 0 touchdown passes. So 0, 0 would be how you would write that first data entry. So that takes care of this one. What's the next lowest? Looks like he had an 18 season as the next lowest. So 1-8 would go there. Okay, next lowest, I see a 23, and I see a 24. So 23, 24. Keep on going here. We see a 25 and a 26. 25, 26. Okay, 1, 2, 3 28s. So 2, 8, 2, 8, 2, 8. Anything else in the 20s? Doesn't look like there's any more in the 20s. Then we have in the 30s a 34, 36, 39. 34, 36, 39. And then we have a 50. 50 way down over here. So that is what we're looking at when we see Brady's stem and leaf plot. Let's do the same thing for Breeze now. Breeze had a 1 touchdown season, his rookie season, 0-1. Next lowest is 11, 1-1. After that, we have 17. And then 24, 26, 27. 24, 26, 27. Looking again, we have a 28. And then we have a 33. A couple 34s. And a 39. With a 43. And a 46. Hopefully I got all those. Obviously, you're going to have to be very, very careful as you do this on a test, because if you get one data entry off, basically all your data is thrown off and all of your calculations are thrown. So it's very important that you do this correctly on the test.